In 1999, Nokia released Snake, pre-built on all new phones that they released. And that's what popularized the name, but the original Snake game released in 1976 under the name Barricades, a full 9 years before the Nintendo would see Super Mario Bros. The fact that we still talk about it today makes it a fairly notable game. The one behind me is fairly notable too, but not for that reason, nor the fact that the head and body don't rotate with the player's movement, no. It's notable because it was programmed in the summer of 2022 for the Super Nintendo, in my own custom programming language. I'm back, doing my dissertation, enjoying my last holiday before work, and then getting and doing said work. It all sort of hit me like a truck. I pay taxes now, so let's do a brief recap of what was going on. Assembly language sucks. It is also currently the only way to make a game for the Super Nintendo. My plan was to design a programming language for this task, and then build the compiler for it, and finally write that up for my dissertation, my final piece of large academic writing needed to get my master's degree. That last video actually helped me out with that a great deal. You see, at the start of a dissertation, you need to explain to your marker why what you're doing is actually worth doing at all. You then need to argue to them why it was difficult. Because if they think it was difficult, they're gonna give you more marks. Retro Games Mechanics Explained is a YouTube channel with over 200,000 subscribers. They have a long-running series diving deep into the technical aspects of the Super Nintendo. I remember watching those and other videos of his after coming home from school and coming home from university, and his work is one of the things that inspired me to do this project in the first place. My supervisor had even used one of his videos as required reading before. So when I woke up and saw a comment on the video from him saying that he'd thought of doing it himself, but that he found it so daunting and agreed with me that the hardware was a challenge, oh, baby, that's figure 1.1. But that's enough of the simp corner. Let's get rid of that. Before any of that, I have a programming language to make. So let's just refresh ourselves on how I was planning to do that. Please, take a seat. Right. I have snacks available. Do you want a snack? Ah, fantastic. Is popcorn okay? Ah, great. Here you go. Oh, hey, focus please, it's starting. And once I have that, I need to make the compiler. For the compiler, I'll need to scan the code into labeled tokens, put those tokens into an abstract syntax tree, and then walk that tree to generate the final code. Now, I've got to this second stage thrice before when working on... Right, yeah, that's enough of that. Right, let's get back to it. I made it in Scala, which I incorrectly complained about in the last video. The more I used it, the more I came to like it. There were quite a few weird decisions in it, but then you come across a case where it'll be used, and it's like your third eye is open. It's like you've become a wizard. At the same time as learning Scala, however, I had to learn about how the Super Nintendo works, which makes it feel like your third eye is being repeatedly stabbed with hot iron. You're not a wizard. This whole thing is magic that was not meant to be comprehended. Compiler step 1. Our source code is too unwieldy for the compiler to actually look through. It sees things character by character, but we have lumps of characters that together make up things of meaning. So our first step is to turn it all into tokens. Like how letters make up every word in the English language, tokens will make up every program possible in our programming language. And like how letters can be lower or uppercase to store some more information, the tokens will contain things like where they were in the program, what they represent. Super Nintendo time! I started by getting an assembler that can make a ROM for the Super Nintendo, and I then got an emulator set up. After that, I was able to follow along a pretty easy tutorial that explains how to turn the Super Nintendo on and get this nice little green screen. By then, writing some data to various registers, I was able to transfer data from work RAM to video RAM to get some graphics in. And with quite a bit more work, I was able to get the correct graphics in. I had no idea about what was going on up there, but I was just happy it was working. Another issue is that the CPU can switch between 8 and 16-bit modes on a dime, and different parts of the Super Nintendo expect you to be writing in a different mode. What this results in is various bugs like the one behind me, where writing in a 16-bit mode to some various address meant that now suddenly my blue bars were sunk down and had also become red bars at points. Through a bit more work, rather than just a bunch of faces, I was able to make a rather appealing looking little map for further tests. Compiler Step 2. Our list of tokens is actually a bit too unwieldy for us to operate on now as well, but the answer is not to reduce the amount of information. Rather, what we're going to do is put it into another data structure that closely resembles how the program's actually going to run. You probably learnt some variation on BODMAS at school, which controls the order that mathematical operations execute. There is only one way to read each equation. Likewise, in programming languages, there is only one way to read each line of source code. So for any clause in the programming language, you can take the point of highest precedence and split it there. This is called the abstract syntax tree, and with it, we now have the program in a form similar to how it's going to be run. But that's enough of the compiler. Let's get back to getting the Super Nintendo to work. It doesn't. I do eventually want things moving about in my game, and that will involve sending sprites to object attribute memory. Now I'm going to show you a bug that happened while I was doing this, but it does involve quite a bit of flashing lights, so you can skip to this timestamp if you'd rather skip that, or I will also play this tone
Wario.
once it's done if you're in a comfortable position and don't want to scroll the video. Here we go! Yeah, this is another example of writing 16 bits where it's expecting 8 bits or vice versa.
Wario.
And bugs like that aren't documented anywhere. This is just old hardware jank. This is just the raw hardware throwing up its guts at you. I don't know what happened here, but after a lot more work, I was able to get an object. It exists! In theory. You see, in practice, there was one small problem. It's not there. It exists in object attribute memory. The emulator will show it to me in object attribute memory. It agrees with me that it exists. It just won't show it. Because it seems drawing objects is disabled by default. Because why would you want dynamic moving pictures on your system about dynamic moving pictures? Regarding the Super Nintendo though, we're starting to reach the limit of what I'm able to do just by programming in assembly myself. To test further, I'm going to need that compiler. Compiler Step 3. This part I both am and am not too familiar with. In the past, I followed this book, Crafting Interpreters, which has explained everything that I needed to know about the last 2 steps. In it, you make a tree-walking interpreter, where you follow the abstract syntax tree to follow the course of the program, and as you do that, you execute the program on a virtual machine. But now, rather than execute the program, for each little step, I need to output a little bit of assembly. And here is the first code snippet that I compiled. This is also very unoptimal. You load 5 into the accumulator, only to later store it onto the stack, and load something else from the stack into the accumulator, before finally adding them together. In future versions of the Tree Walker, it's smart enough to recognize that. Towards the end, the code actually looked something more like this. I think I'll save the optimizations until a bit later though. We have the starts of our programming language. Now, we just need a programming language for the Super Nintendo. To start off with, most languages, such as C and Python, have a standard library that helps the programmer interact with the hardware, writing to files, drawing to the screen, anything that involves the nitty-gritty details. So I need to make my own standard library for the Super Nintendo that'll handle the nitty-gritty details. And by that, I mean a wrapper around the 8 and 16-bit bullshit! I added the ability to write little snippets of assembly in grain. That way, the standard library can still be written in grain, while also being able to access the lower level bits of the hardware. What this means in practice is that I can write this once here, and then never have to think about it ever again. Another issue is graphics. I wrote a little sub-program that can read a PNG in and look at all of its colours. It then turns those colours into a palette. The compiler now lets you treat that palette and the graphics like data, and there's also some inbuilt functions to help you get information about it at compile time. And with all this, we get our first proper compiled program. With this source code and this little guy.png, you get this as the output. Now, this code might be a bit hard to understand in its current state, so future editing me shall make a nice coloured version for you. And that's time for today. We didn't even get to running it on proper hardware, the game of life, Snake! That'll all have to be saved for next time, which will be in a few videos' time. I wanted to come back finishing what I left off on, but that's going to have to wait for a bit longer. So make sure to subscribe if you want to follow along with any of that. It's good to be back. I've got quite a few things planned, and I hope you'll follow along with that as well. So, goodbye for now.